Welcome to Layer 2 Mapping with Nornir and NetworkX. In this video, we are going to perform a Layer 2 mapping using Nornir and network analysis using NetworkX. All the resources of this video are in my GitHub repository in the description of this video. So, first thing here, we need to build our lab. Our lab are done in DevNet NetBox, and let's launch the simulation. Uploading my viral file. And here's something important. Make sure your management network are shared flat network. This way, your computer inside your VPN will be able to access the devices. So launch. Now let's wait until all your nodes are up. Now that our nodes became active, let's push our initial configuration to them. Okay. Switch 1. Now go for switch 2. Switch 3. Four. Five. Finally, now let's wait a bit until all of our nodes are reachable. Okay, now let's go to our lab. Here I'm using Jupyter Hub. If you don't know what it is, go to the description, there will be a link with the Jupyter documentation and installation lib and the installation doc. In our lab, I'm using Nornir 3 and Nornir Napalm 0.1.1, Atmico 0.1.1, Oju 0.1.1, Paramico 2.7.2, requests 2.24.0, NetworkX 2.5, Genie 20.10, PyTX 20.10, and matplotlib 3.3.3. In our scenario, we have the following configuration. Switch farm connected to 3 and 5, and here between switch 5 and switch 6 we have VLAN 10, between switch 5 switch 7 VLAN 20, switch 7 and the server VLAN 20. Here between switch 3 and switch 2 VLAN 10. If you take a look, you see that VLAN 10 aren't fully connected. So if I want that server to talk with that server, that won't happen, because there aren't VLAN 10 in switch 4. Now, the first thing we have to do is gather out our data. So how we do that? First thing, you have to configure your Nornir hosts that I have here to your lab scenario. Here, switch 1 are 172.16.30.91 and go 91, 92, 93, 94, 95, 96, 97. So let's update those values in our host.conf. .yaml. So 91, 92, 3, 4, 5, and so on. So here my groups YAML are empty, and in my defaults I have the username and password admin. So first thing, let's import our libraries into Nornir, netmico send command, and print result. So cool. Okay. Let's list our inventory. And here we have switch 1, this host switch 1, and so on. Now let's use netmico send command to send our devices, show CDP neighbors detail, and show VLAN. Okay, let's print that result. And the VLAN. Now, there's something very important. If you look at results, you have the data as if it was issued to devices. And it isn't very useful for our program. So we need to parse that result in some data object that we can access freely during our programming. To do that, we need to use parsers. So, for only Cisco, we can use the attribute useGenie in our netmiko setCommand task. With that, netmiko didn't use paramiko for access to devices. It used PyATS and Genie for that. So, we have a better looking result. That is an object where we can freely access every entry here. But that approach isn't very good for two reasons. The first one is this way you only can use for Cisco or Genie support devices. So you can't use that for Huawei or MicroTik, HouseOS. So let's make some changes on that implementation to allowing multiple devices, multiple vendors. But the first thing here is how to create a custom task in Nornir. First thing, let's import task and result. And let's build our first custom task, a very simple one, where I receive a task object and whatever variable I want to send. And we'll put as the output the result, host name, task.host, platform, task.host.platform, and the custom variable that we issued here. Now if we call it, we call the name, which is the name that will be displayed at your print results here, show CDP neighbors data. Here will be custom task. The task, that is the name of the function that defines your custom task, and the variable that will be placed as this variable. Here I'm using this is a custom var. Running that, we have for each host, switch 1, host name, switch 1, platform, EOS, custom variable, this is a custom var, one for each. Now, I want to use the Genie parsers, but I don't want Genie to access the devices. I still want netmiko to handle the device connections. I do that because netmiko is thread safe and Genie isn't. So how can I do that? To do that, I'm going to implement show VLAN and show CDP neighbors classes and get only the parse CLE. That is what is interesting for us. So let's do that. And here, the first thing. In our custom CDP parser, the first thing I want to know is what platform that device is. If that device is iOS, I can use Genie show CDP neighbors detail. If that device were HouseOS or Huawei, you could make a different implementation of that. But as my lab is only Cisco, I don't go for that way. So, doing that, defining custom CDP parser and custom VLAN parser. Let's run both of these tasks now. Okay. Now I can print our results. So here we have the CDP neighbors. and our show VLAN. Okay, now that we already have our data, let's build our graph with NetworkX. First, let's import our libraries, which is NetworkX, matplotlib, pyplot to plot our graphs, and some drawing functionalities. Let's first get a list of all of our nodes, which are retrieved from custom CDP result keys. So let's see that. So there we are. All my hosts, switch 1, switch 2, switch 3, and so on. And now let's build our graph. Here I'm using multi-graph, because as a network device I can have a network device connected to another with multiple edges between them. For do that, we instantiate our graph and then add nodes from and nodes that are a list. And there we are. Now if I go for g.nodes, I have all my graph nodes. Now for each node we can add and modify data, doing like that. If I issue g.nodes dot the node's name, like switch 1, switch 2, or whatever, I get nothing, because we still don't have any data in it. But if I manipulate that as a dictionary, we can do g.node dot the node I want to edit, custom data, some data. And now g.nodes.switch1 have custom data and some data in his dictionary. And I can simply delete that, as I will do as in a dictionary. Now g.nodes has nothing. Okay, great. Now let's build our VLAN database in each of our nodes. So how custom VLAN result for switch 6 is built? If you go there, you have the VLANs attribute, and inside the VLAN attributes we have the ID 1, the ID 10, 1002, and go on. Inside 1, we have another dictionary with the VLAN ID, the type, the interface that have that VLAN, and so on. So for each node in g.nodes, let's build our VLAN database list. And what I want for that? For each VLAN inside custom VLAN node result VLANs, or for each key inside this dict, what I mean, 1, 10, 1002, and so on, VLAN data is custom VLAN node results VLANs and ID. If my VLAN data type equals Ethernet, so let's append that VLAN to our node VLAN database. And at the end of that loop, in our node, we are going to add VLANs at node VLAN database. So when that, our node's data, we have for switch 1, we have in his VLAN database VLAN 1 and 10. For switch 2, 1 and 10. 3, 1 and 10. For only 1, and so on. Now that we already have our nodes mapped, let's map our edges. The first thing, for map an edge, we have to issue the module add edge. So g.add the point A and the point B. So it was issued with the first edge between switch 1 and switch 2. Because we are working with a multigraph, we can add as many edges between switch 1 and switch 2 that we want. And now, issuing g.adds, I have our list. Now, if I want to add switch 1, switch 2 with some data, we can do it like that. So, we have now in our adds switch 1, switch 2, index 0, switch 1, switch 2, index 1. Now let's access that data. If I issue g.adds and this tuple switch 1, switch 2 and index 0, which is our first edge, I have nothing. But now, if I issue switch 1, switch 2 and 1, which is the second edge we add, I have its data. And now, because we are working with multigraph, the direction switch 1, switch 2 or switch 2, switch 1 doesn't matter. So if I try to access with a different tuple, changing the order, so here I use switch 1, switch 2, now I'm using switch 2, switch 1. I'll have the same output, meaning that I'm accessing the same edge. Now, if I want to get all the data between the connection switch 1 and switch 2, we issue g.getEdge data, and I have, for the first connection, there is no data. For the first connection, for the second, it is our first index, I have data, some data. Now let's clear our edge. So, to do that, let's take a look at our CDP result. If I run CDP result node switch 4, I get that he have two connections, one with switch 5 and another one with switch 3. And here I have a dictionary with total entries and index. So let's iterate over index. Here I have my first connection, that is with switch 5, and my second connection, which is with switch 3. So, looking at my first connection, I have switch 5 local. Now let's take a look at switch 5 connections. Here's very interesting. See, if I go in node switch 4 and look for its connections, I have a connection with switch 5. The same if I go for node switch 5, I will have a connection to switch 4. In that way, when you are going to add the edges, you always have to look if that specific edge was already entered in our edge list. So, how do I do that? First, iterating for each node in gnodes, our neighbor list is in custom CDP result, our node result index, which is this dictionary. In this dictionary, each neighbor has an index. Index 1, index 2. So, for each neighbor index in neighbors, our neighbor data is custom CDP result, node result, index, neighbor index. Now I'm getting this data. So let's build our edge data. In our edge data, it's very useful that I have the data for nodes and the other point. For doing that, if we want to access that data later, you will have to do data and the node of the edge we want the data. So I have data, an empty dictionary, and starts to create data node. My local interface is neighbor local interface, the remote interface, and so on. And here I'm splitting the device ID and getting only the row's host name. So, with our data build, let's see, does G has the edge node and our neighbor? If this edge exists, let's see if the Z was already mapped. How do I do that? If that local interface is equal to some data local interface. So let's gather all node data from g.getNodeData node and our neighbor. Let's start with saying that edge wasn't mapped yet. So for each data in node's data, our edge data is in node data. So if edge data node local interface equals to neighbor local interface, this edge has already been mapped, and I don't want to map it again. Going through this loop, if it was not mapped, so let's add that edge. So g.add node neighbor and data equals our data dictionary, and so on. Now let's run it. And here we have our data, our edges. Switch 1, switch 3, switch 2, 3, and go on. Our edge data. And suppose that I want to access the connection between switch 1, switch 3, our first edge, and get the data relative to switch 1. So the local interface is giga 0.0/1, the remote interface is giga 0/2, and the remote device is switch 3. If I go the same with switch 3 node, I got the opposite. Now let's create a subgraph. What do I mean? I want to, from that graph, build a graph only with the hosts that have VLAN 10 in his VLAN database. For that, let's create a list that holds the VLAN 10 nodes and iterates of g.nodes. And if 10 is in g.nodes.node VLAN, so let's append that node to VLAN 10 nodes. Now, all my nodes that had VLAN 10 is switch 1, switch 2, switch 3, switch 5, and switch 6. Then let's build a subgraph from that. Okay, now which nodes are in this subgraph? Here we are. And which edges? Here's something interesting. All these graphs came from our main graph G. And we haven't to bother to create again all those edges. With that in mind, let's plot our first graph and now our graph only with VLAN 10. And here we are. Switch 7, 5, 6, switch 4, and so on. Now plotting our only VLAN 10 graph. We have switch 3, 1 and 2, and switch 5 and 6. Here we have something very interesting. We have two isolated islands. What I mean, if switch 5 wants to communicate with switch 1, that isn't possible. But if you see, now that's a visual analysis, you want to do that in some programmatic way. To do so, NetworkX provides the connected components, which get a list of both islands. So we have switch 1, switch 2, and switch 3 make an island of connected devices, and switch 5 and switch 6 another island. And now if you get the length of that list, we have 2. So we have 2 islands. If that value was 1, we have a fully connected network. Now, because that should be a configuration error, what device is missing here? Because our original topology is fully connected. Which device in our original topology that is missing here? To do that, let's search for a path, for example, between switch 2 and switch 6. So, with NetworkX all simple path, I get a list with all possible paths between switch 6 and switch 2. I run that. I got the path is switch 6, switch 5, switch 4, 3, and 2. So, if I go here, switch 6, switch 5, 4, 3, and 2. 6, 5, 4, 3, 2. Okay? Now, with that in mind, for each path in that list, that will be all the possible paths, let's iterate between each node in that path. And if VLAN 10 graph does not have that node, let's print that node having that VLAN configuration. And great, node switch 4 without VLAN configuration. Now we know that. For connect these 2 islands, we have to configure switch 4. Now that we've had already identified some tricks on how to calculate paths between 2 devices, iterate over our graph and look for some nodes, let's get all that data and push to NetBox. So, first thing here, let's import requests. That's the library that we use for HTTP requests. Here I have my local configuration with my API token, the headers that make the authorization works, my NetBox URL, and some configuration here. Now, if I want to create a device, what do I need? So let's go to my NetBox API configuration. And look for the appropriate endpoint. Now, if I want to create something, I must use the post method. So, let's look for the endpoints. For my devices, so I have the sync devices and post. Oh, great! That should be the endpoint that allows me to create a device. Now, what do I need to create a device? Go in here, I need a device type, a device role, and a site. All of them, if you see, are integers. Those integers represent the ID. Now, if I want the device type, what endpoint should I go to get that device type ID? So if I go to device type, and here we are. So I must perform a GET request to the same device types. So let's try out setting no parameter, if everything blank, and execute. And here we go. All my devices. So I have a device type iOS V. The other item I need is the platform. And so get the same platforms. Let's try out. Execute. And here we are. My platform, iOS, and so on. So let's make the same thing here, but programmatically. Let's search for an endpoint that is the same platforms, and let's set the parameter iOS. What the response should I get? And our platform response is that. So count 1, results, ID 2. So my platform iOS has ID 2. Doing that, let's create our createDevice method. First, my API token, the URL of NetBox API, and the endpoint. So first, let's look for our platform, that is a parameter of my function. Then let's look for sites, device hosts, device types. With all that ready, let's make our payload. The name, the device name, which is a parameter of my function, device type, device host, platform, and site. Now let's make our post request and return the status code, which should be 200. So after defining that, let's go to my NetBox to see if there are any devices configured. So no device. And let's, for each node in my graph, let's define device type as iOS V, host DC, platform iOS, site data center, and create a device with node as name, device type, device host, platform, site as defined here. So and it's done. Now let's refresh my devices, and here are all of them mapped. Now my second goal is let's map our device connections. First thing here is what endpoint maps the connection. Here our endpoint is the sync./cables. So cables. And here we are, post the sync/cables. So in order to create our connection, we need termination A type, termination A ID, termination B type, and ID. First, our type is a string, and then the ID is the ID of our interface. Here, because we are connecting interfaces, our termination type is the syn.interface. So let's first get our interface ID for our local interface and for our remote interface. But what data should I have for get that interface ID? The data I need is the device and name, but let's see that in our API endpoint. So if I'm looking for slash interfaces, I will get, I can filter that with device, my device string, and the name. So, with my name as local interface and device local device, let's make a request to get that local ID. Again, using the remote interface and remote device. And finally, let's build our payload. Termination A type is termination type, which is the same data interface, our local ID, and our remote ID. And now, using the endpoint cables, let's make a post request with our built-in payload. And again, return the status code. Now, for each edge in our graph, I'll set our local device as edge, that's a tuple, /edge 0, our local interface as g.edge data edge 0, which is our local device, local interface, our remote device, g.edge data edge 0, remote device, the remote interface the same, and now let's connect our devices. Oh, doesn't create our map function. So, with the function instantiated, let's run it again. And it's done. Now let's see my devices, cables. And there we are, all my connections. Then if I go to my site, my data center, topology, and there it is. And here we are. Now, if you look to our simulation, you got the same topology. So switch 4 connected to switch 3, giga 0/1 and giga 0/3. So switch 4 is connected in switch 3 in giga 0/1 to giga 0/3, and so on. So that's all for now. Thank you for your attention, and to the next video.